Okay, so out in the massive Pacific Ocean, there are these two giant opposing forces that basically run the show when it comes to our planet's weather. They're like this cosmic odd couple, always in a push and pull. We're talking El Nino and La Nina. So let's dive in and figure out exactly what makes them tick. So, this whole story actually starts not in some high tech weather lab, but with fishermen off the coast of Peru. See, they started noticing that every few years, right around Christmas, the ocean would get weirdly warm. So they named it El Nino, which is Spanish for the little boy or even Christ child. Kind of a gentle name for a force that can literally change weather across the entire globe, right? But the little boy isn't alone in this story. He's got an opposite, a counterpart, La Nina, the little girl. And together, this odd couple's constant rivalry dictates everything from droughts in Australia to hurricanes in the Atlantic. And this really breaks down their whole deal. El Nino, that's the warm phase. The trade winds that usually blow across the Pacific, they get weaker. They kind of slack off. And that lets all this warm surface water slosh eastward over toward South America. La Nina, she's the complete opposite, the cold phase. Those same winds get supercharged, they blow stronger, pushing warm water west and letting that deep, cold water rise up. It's a process called upwelling. But here's the key thing you gotta understand. They aren't really two separate things. They're two extremes of one single, massive natural cycle. Scientists call it the El Nino Southern Oscillation, or just ENSO for short. The best way to think about it is like a giant climate pendulum, just swinging back and forth across the Pacific Ocean. So let's focus on the warm kid on the block first, El Nino. When it shows up, its impact is felt far and wide. And man, it can be dramatic. We're talking droughts, we're talking floods. It's a big deal. So how does this all work? Well, as that giant pool of warm water moves east, it basically puts a lid on the ocean. It stops that cold, nutrient-rich water from coming up from the deep, the very stuff that fish need to eat. This completely starves the anchovy populations, and it just devastates the fishing industries in Peru and Chile. At the same time, it's dumping torrential rain on coastal areas that are normally super dry. And meanwhile, clear across the ocean, places like Australia and Indonesia, they're left high and dry, facing terrible droughts. And these effects, they ripple out way beyond the tropics. Just look at the monster El Nino of 1997-98. I mean, this thing was a beast. It sent these ferocious storms just smashing into the California coast. Globally, it was linked to an estimated 23,000 deaths and over $35 billion in damage. It was a huge wake-up call that what happens in the Pacific definitely doesn't stay in the Pacific. For those of us in North America, El Nino winters are, well, they're a total mixed bag. If you're in the north-central US or Canada, you often get a milder winter, which is nice. But the Southwest, which is usually pretty dry, suddenly gets a lot more rain and snow. And then you have the Southeast, which gets this double whammy of being both cooler and wetter. It just completely scrambles the weather map. But, there is one major silver lining. The same atmospheric shifts but cause all that chaos. They also create conditions that just tear apart hurricanes trying to form in the Atlantic. For example, the 2009 hurricane season, that was during an El Nino, and it was the quietest season in more than a decade. So, for people on the Atlantic coast, El Nino can actually bring a bit of a sigh of relief. Okay, so we've met El Nino. Now it's time to turn our attention to his powerful sister, La Nina. And if El Nino brings the heat, La Nina brings the chill. And believe me, her effects are just as widespread and just as profound. La Nina is pretty much El Nino in reverse, and this table lays it out perfectly. Where El Nino brought floods to South America, La Nina brings colder water and fantastic fishing. Where El Nino brought drought to Australia, La Nina brings an absolute deluge. And that silver lining about hurricanes, yeah, La Nina flips that upside down, creating the perfect conditions for a really dangerous and active Atlantic hurricane season. And you should never, ever underestimate La Nina's power. I mean, during the 2010-2011 event, the Western Pacific got absolutely hammered with rain. Huge parts of Queensland, Australia were just underwater. It ended up being one of the worst natural disasters in the country's entire history. A really stark reminder of what she's capable of. And if you need one single statistic to really get the difference, here it is. A study found that the cost of hurricane damages in the U.S. is a staggering 20 times greater in La Nina years than in El Nino years. Let that sink in. 20 times. That's the power we're talking about with this cycle.
So, okay, we've seen the what, the floods, the droughts, all the crazy temperature swings, but why? What's the hidden engine driving this whole epic rivalry? Well, it all comes down to a giant atmospheric seesaw.
This is what scientists call the Southern Oscillation. Just picture a giant seesaw for air pressure. On one end, you've got the Western Pacific, over by Indonesia and Australia. On the other end, the Eastern Pacific, over by South America. When pressure is high in the west and low in the east, the seesaw is tilted one way. When it flips, it's tilted the other. That pressure difference is the engine that drives the winds, and the winds, in turn, drive the ocean.
Let's walk through it for El Niño. So first, air pressure goes up over Australia. At the same time, it drops over South America. Boom, the seesaw has tilted. This pressure change makes those normal east-to-west trade winds get weaker. And without that constant push, that massive pile of warm ocean water in the west just starts flowing back eastward. And there you have it. You've got an El Niño. And then, eventually, that atmospheric seesaw tilts all the way back. Pressure drops in the west, rises in the east. This reversal supercharges the trade winds, pushing even more warm water to the west, which allows all that cold water to rush up to the surface in the east. And just like that, the pendulum is swung back, triggering La Niña. So here's the bottom line, the most important takeaway. El Niño and La Niña aren't just ocean things, and they aren't just atmosphere things. They are the results of this deep, powerful, interconnected dance between the two. A change in one triggers a change in the other, in a cycle that ripples out from the Pacific to touch every single corner of our planet. And that leaves us with a huge question for the future. We've started to understand the rhythm of this incredible dance. But as our global climate keeps warming up, scientists are now asking a really critical question. How will the music change? Is this powerful ocean dance going to become more extreme, more frequent, or maybe something else entirely? That is the multi-billion-dollar question that researchers all over the world are racing to answer.